What kind of shape this equation has? T is running from 0 to 2 pi, or doesn't even matter, from 0 to 2 pi. This is a domain. So last time I was explaining, this is what we call a domain. Very quickly, check this out. The idea is you square left-hand side, not like that. Of course, you do each separately, but that's just like the visual effect of it. This is how you do it. And add the result. So x squared plus y squared is left-hand side squared and added together. Equals 7 cosine t squared plus 7 sine t squared. Who knows right away the answer? What kind of equation do we get? X squared plus y squared equals what? 7 squared. Who missed last class now doesn't understand where the cosine and sine left. So let me one more time explain. If you factor out 7 squared, becomes cosine squared t plus sine squared t. This is going to be your favorite composition for a while, including in calculus 3. That is 1. Cosine squared t plus sine squared t is 1. So it ends up just to be 7 squared. That is a shape called what? Exactly. It's a circle. Circle centered at what? 0, 0. Radius is 7. And that's why I'm not writing it down as 49. Can you do this in a test? That's like very convenient. This is what we do in a test here. Now, how about it's a little bit shifted? That is also important. And I have several videos about that too. How about if it is... One more example. What if x is minus 7? Now let's do equals. X equals 7 plus 3 cosine t. And y is 5 plus 9 sine t. How about this? And say t is again completing the full circle. But with the full circle from 0 to 2 pi, but we don't even know if it's a circle. Yes, it is a circle, but it will be a bit different. Let's see what is the difference here. Idea is still the same. I want to square both sides and add. But before, it was too convenient. Cosine and sine were standing by itself. Now cosine and sine have some additions and subtractions. That makes it a bit annoying. So I would have tell you one additional step. Step 1, isolate. Isolate tricks. Trigonometric functions. Tricks. Cosine and sine. This is going to be a pre-step to do before we just did right now. So I will do x minus 7 equals 3 cosine t. And then y minus 5 equals 9 sine t. That is still not enough, because when I'm going to square right-hand side, it will be 3 and 9. They cannot be factored out, blah, blah, blah. So what I'm going to do, I'm going to isolate completely. I want to have cosine and sine standing by itself with the equal sign, with nothing around it. That means complete isolation. One of the students told me this very nice term, isolate, with E at the end. Isolate. Nice. So we're going to divide by 3, and we're going to divide by 9. X minus 7 over 3 equals cosine t. And y minus 5 over 9 equals sine t. This is a nice isolation. I have cosine and sine standing by itself, equal sign. On the left or on the right, doesn't matter, but they are isolated. And now we're going to do the same idea. Square both sides and add. Cosine square plus sine square gives you 1. So, let's see. I'm going to square. Basically, it's like this, but this is not the correct way to show it. You're supposed to put on each side, blah, blah, blah. But the idea is you square both sides, left-hand sides and right-hand sides, and add them together. So, plus You don't have to simplify. X minus 7 over 3, everything squared, equals cosine squared t. Y minus 5 over 9 squared equals, oh, well, I skipped this. Okay, fine. I'm too slow. Sine t. And now I'm adding this together. And it will give me this new equation, x minus 7 over 3 squared plus y minus 5 over 9 squared equals cosine squared t plus sine squared t. Which is 1? Right hand side is 1. So equation becomes x minus 7 over 3. At some point I want to write down as 9 squared plus y minus 5 over 9. And at some point I want to write down as 81 equals to 1. This is the equation I have right now. The goal was to get rid of t, to see what kind of equation we're having in Cartesian coordinates. So maybe let's write down goal from parametric we want to convert to Cartesian. Cartesian means sometimes called square coordinates or rectangular. Yes, sometimes they call it rectangular coordinates. Parametric from rectangular coordinates. The goal is to get rid of t. Get rid of t. To get rid of t, we want to make sure that sine square and cosine square will be added together. Then t goes away because it gives you 1. We got this. Do you know the shape? If you check the lecture on Monday, I mentioned it. Yes? It's an ellipse. If you scroll very, very far to the top, I mentioned this to you. Ellipse is a circle. See? Ellipse is a circle, but just it doesn't have one radius. It has 2 radii. And it looks like this. Instead of r squared to be on the right, it has 1 on the right. And then 2 radii. 1 radius represents how much we're stretching to the right and to the left. And the other radii represents how much we're pushing up and down. So the smaller the push. When they are the same, it gives you ellipse with 1 radius. That is a square. What did I just say? That is a circle. That is not a square. If the numbers in denominator are the same, so 3 and 9, for example, 9 and 9, then it would be a circle. But in this case, it's an ellipse. Ellipse. Centered where? Centered at. Do you know? X sub 0, y sub 0 equals what? 7 and 5. This is important. This is the shift. So this shift represents the center. The center is at 7 and 5. And now we have radius 1, which is radius that associates with x-axis, how much we're stretching the x-axis. So let's call it A. A is 3, not 9. And B is 9. That is a stretch for the y-axis. So you can imagine it will look like this. Here's the x and y axis. Find the center 7 and 5. 7 to the right, 5 up. Here's the center 7, 5. Now there's a 3 stretch on the x-axis. So it's going to be 7 minus 3 and 7 plus 3. And then 9 stretch up. So the ellipse is looking up. Like so. If they both 9 and 9, then the radius will be 9. So that will be a circle. Does that make sense? What do you think? We are redefining simple shapes, which we learned from school, using parametric equations. That is the idea here. Finally, how about the other way around? If I ask you this question on the test, Example. Can you write down which of the following represents the parametric equations? Write down parametric equations. What kind of? Circle centered at 10 and 13, radius 30. Can you write it down? The shape is always the same. Let me show you. It is the formula. It's a kind of formula, but you can also just understand. It's going to be x minus x sub 0 equals radius, so let's call it r, cosine t, and then y minus y sub 0 equals r sine t. And this takes us nicely to the 9.3, which are polar equations. We're not going to start it right now. But the center here is x sub 0, y sub 0, which, yes, that is a center. And r is the radius. And we're going to rename t to be theta next week. And that takes us to the definition of the parametric equations. So what should I write down for the circle they're asking me? Parametric equations is a system. So you see, I don't need, let me show you this idea. Write down parametric equations, not the Cartesian. So Cartesian, C-A-R-T, Cartesian equation, we know how it will look like. Do you know? What is the center in Cartesian equation? How to write down the circle centered at 10, 13, radius 3. X minus 10, then what? Squared minus 13 squared equals 3 squared. Do you all agree? If you don't, I reviewed it at the very beginning on Monday of this lecture. At the very beginning, that's the formula in Cartesian equation, which we know from school. Hopefully you know from school. Thank you, very good. Now we're learning in parametric equations. So parametric will be a system. That's the formula I just showed you, which is x minus what? Minus 10 equals what? 3 cosine t. Y minus 13 equals 3 sine t. You can always check. It should be the same. If you square left-hand sides and add them together, it will be x minus 10 squared plus y minus 13 squared equals 3 squared. Make sense? Because sine squared and cosine squared gives you 1. So it's the same thing. You can easily jump from 2. So we can ask you both, this one or that one. Sometimes you will not see it written as this way. Usually people will rewrite it as x equals and y equals. And that's when you see 10 and 13 being on the right-hand side. 10 plus 3 cosine t. 13 plus 3 sine t. That is the final answer. It's the same thing, but it's usually written like so. X equals stuff and y equals stuff. Answer. Can you do that on a test? What do you think about that? Questions, ideas, suggestions, critics, what do you think about that? Let's stop this and practice more derivatives.